It is indeed possible to encounter a ground fault circuit interrupt a receptacle fed from an arc fault circuit interrupt a protected circuit. While the National Electrical Code does not explicitly prohibit this configuration, it's not considered a common or ideal practice for several reasons. An AFCI breaker is designed to provide protection against arc faults and the circuit it feeds. An arc fault is an unintentional electrical discharge between two or more conductors. These faults can generate heat and potentially cause fires. The AFCI breaker detects these arc faults and quickly interrupts the circuit to prevent a fire hazard. On the other hand, a GFCI receptacle provides protection against ground faults and the circuit it feeds. A ground fault occurs when electricity unintentionally flows to ground through a path other than the intended circuit. This can happen when a person comes into contact with a live wire or a faulty appliance. The GFCI receptacle detects this ground fault and quickly interrupts the circuit to prevent electrical shock. Now let's consider the scenario where a pole light is plugged into a GFCI receptacle that's fed by an AFCI protected circuit. When the pole light is plugged in, the current flows through the GFCI receptacle first. If there is a ground fault in the pole light, the GFCI receptacle is designed to trip, opening the circuit and cutting off the power supply. This action of the GFCI receptacle tripping can also cause the AFCI breaker to trip. This is because the AFCI breaker is designed to detect any interruption in the current flow, which is exactly what happens when the GFCI receptacle trips due to a ground fault. While this combined protection might seem advantageous, it presents several challenges. Firstly, it can be very confusing to troubleshoot electrical issues on a circuit with both AFCI and GFCI protection. When a trip occurs, it can be difficult to determine whether the AFCI breaker or the GFCI receptacle is the source of the problem. Both devices perform distinct protection functions, and understanding which one tripped and why requires careful investigation. Secondly, ensuring that both the AFCI breaker and the GFCI receptacle are working properly can be difficult. Regular testing is essential to verify that each device is functioning as intended. However, the interaction between the two devices can sometimes complicate the testing process. Thirdly, a potential safety hazard can arise if the GFCI receptacle is not properly installed or maintained. A faulty GFCI receptacle might not trip when a ground fault occurs, leaving individuals vulnerable to electrical shock. Similarly, a malfunctioning AFCI breaker might not detect arc faults, increasing the risk of electrical fires. For these reasons, it is generally recommended to use either an AFCI breaker or a GFCI receptacle on a given circuit, but not both. This approach simplifies troubleshooting and ensures that the circuit is appropriately protected without the added complexity of overlapping protection devices. In situations where both arc fault and ground fault protection are desired, it's often better to use a dual-function AFCI/GFCI breaker. These breakers are designed to provide both types of protection in a single device, simplifying the circuit and reducing the potential for confusion. Now let's consider the specific scenario where the outside receptacle is supplied from a bedroom receptacle. While this wiring configuration might not be a direct violation of the National Electrical Code, it's not considered a good or ideal practice. The NEC provides minimum safety standards, but it's important to consider the overall safety and functionality of the electrical system. It would be preferable to run a dedicated new circuit to the outside receptacle. This dedicated circuit would provide a more reliable and safer power supply to the outside receptacle, and it would also isolate it from the bedroom circuit. This isolation is beneficial for several reasons. Firstly, it prevents any potential electrical problems in the outside circuit from affecting the bedroom circuit. For example, if there were a ground fault or a short circuit in the outside lighting, it would not cause the bedroom circuit to trip, which could be particularly disruptive at night. Secondly, it ensures that the outside receptacle has sufficient power available to operate any connected devices without overloading the bedroom circuit. Outside receptacles are often used to power tools, landscaping equipment, or holiday lighting, which can draw significant amounts of current. If the outside receptacle is sharing a circuit with the bedroom, there is a risk of overloading the circuit and causing the breaker to trip. Thirdly, a dedicated circuit provides a more convenient and flexible power supply for the outside receptacle. It allows for the installation of additional receptacles or lighting fixtures on the outside circuit without impacting the bedroom circuit. When running a new circuit to the outside receptacle, it's important to follow all applicable codes and regulations. This includes using the correct wire gauge, installing appropriate overcurrent protection, and ensuring that all connections are properly made. Additionally, it's important to consider the environmental conditions where the outside receptacle is located. If the receptacle is exposed to weather, it should be a weather-resistant type and installed in a weatherproof enclosure. If the receptacle is located in a damp or wet location, it should be GFCI protected. There are specific national electrical code requirements for GFCI protection in various locations, including outdoor areas, bathrooms, kitchens, and other areas where water is present. Understanding and complying with these requirements is essential to ensure electrical safety. In conclusion, while it is possible to find a GFCI receptacle fed from an AFCI protected circuit, it's not a recommended practice. It's generally better to use either an AFCI breaker or a GFCI receptacle on a given circuit, or to use a dual-function AFCI/GFCI breaker. Additionally, it's important to ensure that all electrical wiring is done in accordance with applicable codes and regulations, and that all devices are properly installed and maintained. By following these guidelines can help to ensure the safety and reliability of electrical systems. When troubleshooting electrical problems, it's important to have a systematic approach. Firstly, identify the symptoms of the problem. What is happening? When does it happen? Where does it happen? Secondly, gather information about the electrical system. What is the voltage of the circuit? What is the amperage of the breaker? What type of wiring is used? Thirdly, inspect the electrical components. Are there any loose connections? Are there any damaged wires? Are there any signs of overheating? Fourthly, test the electrical components. Use a multimeter to check the voltage, current, and resistance of the circuit. Use a circuit tester to check for ground faults. Fifthly, analyze the data and draw conclusions. What is the most likely cause of the problem? What steps need to be taken to fix the problem? Sixthly, implement the solution. Make sure to follow all applicable codes and regulations. Test the system to ensure that the problem is resolved. Common electrical problems include trip breakers, short circuits, ground faults, open circuits, and voltage drops. Trip breakers are often caused by overloading a circuit. Short circuits are caused by a direct connection between two or more conductors. Ground faults are caused by a leakage of current to ground. Open circuits are caused by a break in the circuit. Voltage drops are caused by excessive resistance in the circuit. Electrical safety is paramount. Always turn off the power before working on electrical circuits. Use appropriate safety gear, such as gloves and eye protection. Never work on electrical circuits when you are wet. If you are not comfortable working on electrical circuits, call a qualified electrician. The National Electrical Code, or NEC, is a set of standards for safe electrical installation and maintenance. The NEC is updated every 3 years. It is important to be familiar with the NEC requirements for your area. Local codes and regulations may also apply. These codes may be more stringent than the NEC requirements. It's important to check with the local authorities to determine the applicable codes and regulations. Electrical systems should be inspected regularly to ensure that they are safe and in good working order. Inspections should be performed by a qualified electrician. Regular maintenance can help to prevent electrical problems. Maintenance tasks include checking for loose connections, replacing damaged wires, and cleaning electrical components. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the breaker and prevent electrical shock. Grounding systems should be inspected regularly to ensure that they are functioning properly. Surge protection can help to protect electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protectors should be installed at the service entrance and at individual outlets. Lighting protection systems can help to protect buildings from damage caused by lightning strikes. Lighting protection systems consist of lightning rods, conductors, and grounding electrodes. These systems provide a path for lightning current to flow to ground, which helps to prevent damage to the building. Energy efficiency is an important consideration when designing and installing electrical systems. Energy-efficient lighting appliances and equipment can help to reduce energy consumption and save money. There are many different types of energy-efficient lighting available, including light-emitting diode, or LED, compact fluorescent, or CFL, and halogen lamps. Energy-efficient appliances and equipment are typically labeled with the Energy Star logo. Renewable energy sources, such as solar and wind power, can be used to generate electricity. Renewable energy systems can help to reduce reliance on fossil fuels and reduce carbon emissions. Electrical safety training is important for anyone who works with electrical systems. Training courses cover topics such as electrical hazards, safety procedures, and first aid. It is important to stay up to date on the latest electrical safety standards and regulations. The electrical industry is constantly evolving, with new technologies and standards being developed all the time. Staying informed about these changes is essential for ensuring electrical safety and efficiency. The National Electrical Manufacturers Association, or NEMA, is a trade association that represents electrical equipment manufacturers. NEMA develops standards for electrical equipment and provides technical information to the electrical industry. The Institute of Electrical and Electronics Engineers, or IEE, is a professional organization for electrical engineers. IEE develops standards for electrical engineering and provides technical information to the electrical industry. Underwriters Laboratories, or ALL, is a safety certification organization that tests and certifies electrical equipment. UL-listed equipment has been tested and found to be safe for its intended use. The International Electrotechnical Commission, or IEC, is an international standards organization that develops standards for electrical and electronic equipment. AEC standards are used in many countries around the world. Continuing education is important for electricians and other electrical professionals. Continuing education courses help to keep electricians up to date on the latest electrical codes, standards, and technologies. Many states require electricians to complete continuing education courses in order to renew their licenses. There are many different types of electrical careers available, including electrician, electrical engineer, electrical contractor, and electrical inspector. Each career requires different levels of education and training. Electricians install and maintain electrical systems. Electrical engineers design electrical systems. Electrical contractors manage electrical projects. Electrical inspectors inspect electrical systems to ensure that they are safe and in compliance with codes. The demand for skilled electrical workers is expected to grow in the coming years. This growth is driven by the increasing demand for electricity and the need to upgrade aging electrical infrastructure. A career in the electrical industry can be rewarding and challenging. It offers the opportunity to work with cutting-edge technology and make a positive impact on society. Always follow safety precautions when working with electricity. If you are unsure about something, consult a qualified electrician.